video is part of an online course of multivariable calculus, and I'm going to talk about spherical coordinates now. So let me start. We can represent the point by coordinates rho, phi, and theta, okay? So instead of having the Cartesian coordinates x, y, z, we can represent this by the triple rho, phi, and theta. And what are they? So let me graph x, y, z axis. And then if we have the point P with the coordinates x, y, z in here, the Cartesian coordinates, then I say that the distance from the point to the origin, I'm gonna call it rho. So basically rho, we write it by that, is the distance from the point to the origin, and it's always greater than or equal to the 0. It's just because it's positive, it's the distance. Then we have phi. What is phi? Phi is basically the angle from OP to the positive z-axis here. So it's the angle between OP and positive z-axis. Okay, so phi is always between 0 and pi. If phi is equal to 0, then we get the positive z-axis. If phi is equal to pi, so basically OP would be here, so that I have the full angle pi, then it would be negative z-axis. Okay, so phi is basically the angle from positive z-axis to the OP. And then we have theta. We define theta as before. So theta is as before, as like the polar coordinates or the cylindrical coordinates. It's what? It's the angle between R and positive x-axis. What is R? R is basically here. I'm gonna have a line from the point P to the xy plane, and then this is my R. The angle theta is this angle. Theta is counterclockwise, so it's the angle that is counterclockwise, and it's the angle from, I can say that from OP to the XZ plane as well, you see, from XZ plane. I should say positive XZ plane, okay? So look at that. This is also R. And if you might notice that this is my x coordinate of the point, this is my y coordinate of the point, and then this is the z coordinate of the point P. So the point x, y, z, the point P, can also be represented as rho, the distance from O, the origin, to the point. Then phi is the angle from OP to the positive z-axis, and theta is the angle of R to the positive x-axis. Or I can say that it's basically the angle from OP to the positive xz plane. Okay, so now if I'm given x, y, z, and if I ask for rho, phi, and theta, how can I write rho, phi, and theta in terms of x, y, and z. I can say that rho is the distance from the point to the origin, so the formula for the distance is x squared plus y squared plus z squared inside the square root. Then z is what? To find the phi and theta, I can consider the plane that is passing through the point P and the z-axis. So I'm gonna graph this plane in here. So on a separate graph, it would look like this. So I have z-axis. That's my point P. This is the distance from the point to O. Then just assume that because I'm considering this plane in here, this is basically R. Let me write R in here, and then here I have Z. Okay, I hope it makes sense. So what is R? This distance that I have in here is square root of z squared plus r squared, considering this right triangle that I have in here, the right triangle O, Z, and P. Okay, I have this, and r is, as before, as the polar coordinate, would be x squared plus y squared. And then this angle that I have in here is the angle phi. If I consider this right triangle in here, you see phi is basically this angle that I can get it from rho, which is here. This is basically rho, and it would be rho cosine phi. Okay, or I can say that r that I have in here, which would be the same as this side in here, r would be rho sine phi. Okay, so I can say that phi would be the arctan of r over c, but we just need one or two of these equations to find r. And then theta is as before, because the tan of theta, it would be y over x. Okay, now considering again this shape that I have in here and that shape that I have in here, I can say that x, y, and z. If I'm given rho, phi, and theta, what is x, y, and z? Okay, look at x. X is right there. Okay, so considering this right triangle in here, I can write r cosine theta would be my x. So r and then cosine theta. What is r? R, looking at this right triangle in here, which would be the same as this one in here, r is rho sine phi. So instead of r, I write rho sine phi. Okay, for y, I have the same idea. Looking at y in here, which would be this distance that I have in here, would be y would be r and then sine theta. Okay, this right triangle that I have in here, so it would be r sine theta, but instead of r, I can use this right triangle with phi, and I'm gonna write rho sine phi. So, rho sine phi. And looking at z, we had it from before, z is equal to rho cosine of phi. Okay, so one more time, that rho is always positive, phi is between 0 and pi, and theta is between 0 and 2 pi. These are the bounds for rho, phi, and theta. Okay, let's go over some examples. And the example 1, we're gonna see what is rho equals to a. Well, equation of the rho. Rho is x squared plus y squared plus z squared. Okay, rho square is equal to that. So if I square both sides, rho square would be this, which would be equal to a square. It's a sphere. So it's a sphere with radius a and center 0, 0, 0. Okay, so let me graph that sphere. This is y-axis, this is x-axis, and then this one is the axis. And I have the sphere in here. Let me change the color of that. Okay. So when rho is equal to just the number in the spherical coordinate, it's a sphere of radius a. Okay, and inside the sphere I have something very cool to say, is that phi, that which phi basically measures the distance from the North Pole, which is here. This, I can consider this as the North Pole, and phi measures distance from North Pole. Okay, so looking at these concentric circles, these are called latitude in geographic, right? So I can say that phi corresponds to latitude, starting at 0 and increasing to South Pole. South Pole is basically right there. Okay, and when phi is equal to 0, we are in the North Pole. When phi is equal to pi over 2, we are in the equator. And when phi is equal to pi, we are in the South Pole. Right? And now looking at theta, theta measures what? Theta measures is the distance from the positive x-axis. So it measures how far you are on the east or west. Measures how far you are on east or west. Okay, so we can consider like these circles from North Pole to South Pole. These are like longitude. So theta corresponds to longitude, and phi corresponds to latitude. Right? So that was the first example. Rho equals to phi. Let me go over another example. Theta equals to pi over 3. What is that in spherical coordinate? I'm gonna graph it, and I'm gonna give you some time to think about this. Okay, when theta is equal to pi over 3, I'm basically calculating an angle counterclockwise from the positive x-axis. So this is pi over 3. Have this, and then look at here that the rho and phi are free, right? We don't have any restriction on rho and phi. That's why rho can be from 0 to positive infinity, right? And phi can be from 0 to 2 pi. That's why we just get this half plane, right? It's a half plane. Half plane. Theta equals to pi over 3 is like a half plane. And the next example, what is phi equals to pi over 6? Okay, I'm gonna graph x, y, and z, and I'm gonna give you some time to think about this. Z, and then x-axis. So when phi is equal to pi over 6, I'm considering the angle from the positive z-axis. So I have pi over 6 in here. Okay, and then theta is free, meaning that theta can be from 0 to 2 pi. So I will make it round. Let me make it a little smaller so that I have space to graph it. And this is pi over 6. Yeah, and rho is also free, so it's a cone, but it's a half cone. It's just because theta is equal, phi is equal to pi over 6, so it's from the positive, it's on the positive z-axis, so it's a half plane, half cone actually. It's a half cone. So theta is free, so it's gonna rotate about the z-axis, because theta can be from 0 to 2 pi, so the angle from the positive x-axis or xz plane would be from 0 to 2 pi to make it the full shape. Now let me show it to you, all the graphs that we considered. So as you see, this is called the spherical coordinate. This is the rho from the origin to any point. This is the angle for rho, and then this is phi from the North Pole to the South Pole. You see, it's the angle phi, and then this is for theta that measures from 0 to 2 pi. Okay, this is the coordinates for spherical coordinates. Now let's look at rho equals to 5. I needed to write the equations in here using parametric equations to use the program, but this is actually rho equals to 5. You see, rho equals to 5 is basically a sphere with radius 5, and theta is free, 0 to 2 pi to make it full round, and then phi is from 0 to 2 pi. So it's a sphere. The other equation that we considered is theta equals to pi over 3. So pi over 3, you see rho is free, so rho can be from 0 to infinity, and then phi can be from 0, North Pole, to pi, South Pole. It's like that. And then theta is equal to pi over 3, so the angle from the xz plane, it's pi over 3. You see, it's like that. It's a half plane, and this is phi equals to pi over 6, so the angle from the positive z-axis is pi over 6. Theta is free, so make it round, and then this is equal to the half cone. It's like that. Okay, I'm gonna give you one more example to change the points from the Cartesian to spherical. What is 0, 2 root 3, and negative 2 in spherical coordinates? How can I represent it in spherical coordinates? Well, I need to find rho, phi, and theta. Rho is the distance from the point to the origin, which would be 0 square, 2 root 3 square plus 2 square, which would be what? This is 4. This is 12, so it's a square root of 16, which is 4. And then I have z equals to rho cosine phi. Z, the third coordinate, is negative 2. Rho is 4, and then cosine of phi. So I can say cosine of phi is equal to negative 1/2. What is the angle between 0 and pi, whose cosine is 1/2, it's negative 1/2. So phi is 2 pi over 3. right? And then I know that the tan of theta is y over x. So y is 2 root 3 over 0. So this is positive infinity. What is the angle between 0 and 2 pi whose tan is positive infinity? Theta is pi over 2. So the point 0 to root 3 and negative 2 basically corresponds to 4, 2 pi over 3, and pi over 2 in spherical coordinates. Okay. On the next video, we're going to see how to compute triple integrals in spherical coordinates.